Welcome to the program, Bernardine.
Thank you. I'm more than happy to acquire more uncles, so and aunts. I welcome it. Thank you for having me. Should I share my screen now, Uncle Mahendra?
You can call me anything. I don't mind.
Okay. And you can hear me okay. So hi, my name is Berardine Dias, as you have been told, and I am actually named after my mom, who is Bernardine. And I would like to talk to you about field robotics. So there was a little bit of an intro about what robotics means, and that's highly debatable, honestly. I worked in the Robotics Institute at Carnegie Mellon, which is probably one of the biggest groupings of world-renowned roboticists in the world, and we could never agree what robotics actually meant, because we had everyone from mathematicians to artists in our group, and it took all of us to really make robotics mean anything. So I will not try to define it because it's clearly not definable. But I will say that it's not only about making machines more human-like. It's more about understanding what machines might be capable of, and sometimes using machine models to understand what it means to be human. So there's a lot of philosophy in robotics, and I'm more than happy to discuss any of this that anyone is interested in. But today I want to talk to you about field robotics. So field robotics is different simply because it's not robotics in the lab. So you can't control a lot of the elements in the environment. It's about taking technology out into the world. And that brings with it another whole slew of adventure. And really, there's no better word to describe it because it's always an adventure. Nothing ever goes as planned. And yet, if you don't have a plan, then life is increasingly miserable. So what I would like to do is start by telling you my origin story. For any of you who are fans of Marvel or DC comics, and when they talk about these different superheroes and villains, the origin story always defines the character. And I think in my case, that's not any different. So I was born and raised in Sri Lanka. That middle picture here, the second one, is my family. So that's my mom, my dad, actually my grandfather in the background, my maternal grandfather. And these were my siblings. So that's me. I was the second eldest of 6 kids. And so we had just enough to do like a 6-person semi-cricket team. And our siblings are incredibly close. We all still are very nuclear family. We keep in touch, even though we are spread around the globe. And I think a lot of my character was really forged within this family structure, and it's something I'm very proud of, actually. And as Uncle Robin alluded, we came from very humble beginnings, and I think in many ways that's what has helped us succeed, because we embraced that and learned a lot of things from our parents about focusing on education and what things were important in life. As Uncle Mahendra referred to, I have many, many interests. So I actually studied Udarata Netun for about 8 years of my life. And then I have performed in some places. And then when I came to the US for university, I actually started choreographing and did fusion dance. I've studied Latin dance. So that's me doing one of my performances. I think in college I started a troupe called Rangana Surangana. But it was funny because it was kind of fun teaching other people about your culture through dance, and learning about other dances and how they might mix. And so I've certainly enjoyed a lot of things about Sri Lankan culture and how to share that when I was forced to come to the US. I came to the US actually in '94 simply because at that time with the Civil War, it was really one of my only choices to go to university in any reasonable time period. And I was lucky enough to win a scholarship. So I came to Hamilton College in upstate New York. And I was originally a physics major, ended up double majoring in physics and computer science. And I minored in women's studies. I really enjoy a variety of subjects. Even for my London A-levels, I did math, further maths, physics, and then I did accounting because I thought accounting was fun. And it's to my parents' credit for allowing me to pursue all of these passions. So Hamilton College was really incredible for me because it was a liberal arts college, and it was the first time coming from a system in Sri Lanka where you increasingly specialize, where they really encouraged you to broaden your horizons. So to graduate, I had to take 3 sports, pass a physical fitness test, pass a swim test, take classes in humanities, social sciences, and so on, and arts. So I did sculpture and economics and philosophy and so on and so forth. And then I actually combined my 2 specialties, I guess, physics and computer science, to do a senior honors project in robotics. So that's where sort of my interest in robotics came, because it was a natural marrying of physics and computer science, and ended up then applying to both physics and robotics for graduate school, and got into both, which was to me at the time very surprising. So I had to make a choice about going into physics, and my passion then was to try and solve the fusion problem and energy. So I had worked at University of Wisconsin's tokamak, the torus, and working on the fusion problem during one of my summer internships, all going to robotics. And coming to Carnegie Mellon for that visit really changed my mind, because I think a lot of places, including, you know, Princeton and MIT, all the interviews were very much like, oh, what was your thesis about? Can you explain this to me and that to me? And when I came to Carnegie Mellon, none of that was true. They just asked me, you know, how are you going to change the world in 20 years? That's what we want to know. And I thought that was really exciting. And I would go to professors' offices, and they had books on Chekhov's plays as well as artificial intelligence. And to me, that was like a dream world. So that's where I ended up. I studied robotics, got my master's and PhD, and ended up staying on as a professor for about 13 years. And in the meanwhile, I met this guy, Brett, who was also in robotics. I think a shocking number of women in robotics end up marrying men in robotics. So maybe that was it, and produced these 2 monkeys over here. And so that's the origin story. And as it develops, these are some of our pictures of these 2 growing up. So this is actually in Australia. My husband's Australian by birth. And I wanted to show you that my kids, you know, this is my daughter who, before she was 2, she could get the batteries out of most toys with a screwdriver. And this is my son, who, you know, they grew up around robots. And so to them, it's not anything very spectacular. I always say that they'll probably be bored before they're teenagers, simply because everything that other people find so exciting, they've already experienced. But they certainly have pushed all of my limits in understanding of what is possible, and they amaze me every day. And both of them are really interested in both math and science and engineering, and so we'll see what they accomplish as things develop. Okay, so what I wanted to do today is take you on a journey. This is not a chronologically ordered journey. It didn't make sense to do that. But I'm going to try and give you a sense for different projects that I have done in the field. And in this first one about Canada and the last one about India, I'll give you more technical details, but in the middle ones, I'll stick to stories. Okay, so let's start in the Canadian Arctic. This was really where I learned what it meant to do field robotics. So we ended up going to this island here called Devon Island. It's almost at the North Pole. And our mission was to try and figure out if we could get a robot that was entirely solar powered to circumnavigate a pole, so go all the way around the pole, ideally autonomously and entirely powered by the sun. So here's the robot. This is $1 million robot with mountain bike wheels. It was sponsored by NASA, and most of the expense was really in this, at the time, state-of-the-art solar panel, which was custom built for this robot. And this is the team. So there's me. This is summer in the Arctic, and I was freezing. I mean, I'm from Sri Lanka. I still freeze in the winter. The local people, I mean, our camp was guarded by 15-year-olds with shotguns, which in itself was a little disturbing, but that's their life. So those were the Inuit kids. They were in t-shirts or bare-chested. They were walking around. They were so happy, and we were freezing in parkas. But in the summer, in Devon Island, there's 24-hour sunlight. So there's 2 a.m. in the morning, you'll see 2-year-old kids playing out on the streets because it is 6 months of sunlight and then 6 months of dark. And in the dark time, nobody ever comes out, and it is even colder. So our job was to try and get this robot, which we built, to navigate the pole, to go or complete a circuit around the pole. And this is just to give you a sense for what the landscape was like. So this guy here, Dave Berardine, he was the team lead. And then there were 3 students on this project. So that's Chris Urmson, who now is the leader in the autonomous car industry. This is Paul Tompkins, who is now working with Blue Origin. So he's kind of a space guy. And that was me. That was the 3rd one. And then these 3 were staff members. So this is the team that went. And we were able to complete 2 circuits. This was an example of one of those circuits. And let me give you a sense for what it took. So at the time, because we have to get everything done on board in computers that were less powerful than you and I probably have today, we could not upload a full map like this at the resolution that we needed to. So we basically had these maps that smaller maps that were detailed, we would overlay on top of each other. And so we'd basically drive off one map into the next map and so on and so forth. And that's how we figured out how to get around this whole thing. So any robot probably the only thing roboticists will agree upon is that there is a sense, think, act loop. So you sense your surroundings, you think about what you must do, you act, and then you keep doing that over and over again. And in many ways, humans operate the same way. So this is sort of what we would do. We would get the state of the world. This usually meant grabbing images and performing stereo calculations from cameras in this case. So we'd get images like this. And then we generate what's called a traversability map. So it looks something like this, and green is good, red is bad. And then we would insert that traversability information into another map called the navigation map. And this was what I was in charge of. And then within that navigation map, we're trying to optimize the next movement we take. So you'll see a get state here, and this time we are getting the state of the robot, because the robot itself is very complicated and has, you can monitor the state of each wheel, all the motors, and so on and so forth. So once you have that state, you couple it with this state, you plan a path to that goal, and then you select one arc to execute, and you issue a drive command, and then that whole thing goes over and over again. So that's how this robot worked. So this is just showing you an example of that traversability map where, this part it's safe. And then here's this big rock, which would have upended the robot, and that shows in red over there. So this was the kind of work that I did, where I would plan in maps like this. And this was my goal region that I was trying to get to. And this is sort of the path that the robot is taking. And I would try to avoid these white blobs because white meant obstacle. There's a gradation of gray there. So the blacker the better, because that means it's free or unknown. So you try to stay within the known space, execute arcs that the robot can actually manage to maneuver, and keep doing that until you reach your goal. And then you put down the next goal, and so on and so forth. So all of that, perhaps it's a little dry. I don't know. It depends on what you are interested in. But perhaps what's more interesting is the operating conditions. So this was a NASA base. And astronauts from around the world would come there to train. Primarily, it was a Mars simulation base. So they would simulate for operations on Mars there. And so we had a lot of challenges, even just to get the robots there. We had to custom build the crate that carried the robot, and this was custom built according to the specifications of the shipping company. There are no standard, you can't UPS or DHL or whatever it is, FedEx to the Arctic. So this is all custom jobs. And so you build this huge crate, you take apart the robot, you do foamed layers so that you can protect it all. And then it turned out the shipping company hadn't understood what's called the piano moving problem. They basically gave us the internal dimensions of the plane, but then had forgotten that it had to actually go through the door into the plane. And tried to load it, realized it couldn't fit through the door, and then happily unpacked the crate and just took out the part on top, not realizing that it was layered foam. And so we arrived at the Arctic to find only part of our robot there, and then had to go back and do dumpster diving in Iqaluit in California, in Canada, to try and find the rest of our robot and then bring it. So it started out already an adventure, but we got it to work. And so our 1 week trip, which was supposed to be my trip, that I was only going to be there for a week, ended up being 3 weeks. This is our operations tent. So we lived in tents. Operations were tents. And usually in the summer in the Arctic, you get 1 centimeter or 1 inch, I can't remember which, of rain. And we got 9 just the 1 week we were there. So we were miserable. We didn't have rain gear. So Red Whittaker, who was sort of the main, he's the godfather of field robotics. And he was the main investigator on this project, even though he wasn't there. He was a former Marine, so he made a call to the Marines, and the Marines flew over and actually dropped rain gear for us with parachutes. It was kind of hilarious. So I have lots of interesting stories about this, but you'll see one of the hardest things to do was to actually get this operation running 24 hours and get enough sleep during bright sunlight. So you'll see me at the back here actually asleep. Which, we had to take turns working, sleeping, getting stuff working if something wasn't, and so on and so forth. And it's a fairly intense experience. And this is sort of where we were living. So these were the living tents where we used to sleep. And then there was sort of a main tent where we would all eat. We would come to eat. So everybody in the whole camp. And usually there were close to 100 people from around the world doing different experiments. And this is the robot trying to cross different types of terrain. So there's water, there's snow, and so on and so forth. I will mention that there were 2 requirements to be able to stay on this camp. One was you had to learn to drive an all-terrain vehicle. So it's one of these. And you had to pass a driving test for that. And the other one was you had to learn to shoot a shotgun well enough that you could hit a box that was 15 feet away. And again, you had to pass that test. And this was in case of polar bear attack. So apparently polar bears, either if they hunt you, you kill them or they kill you. And there's no in between. So luckily I did not have to practice that. So the only time I've ever fired a weapon in my life was the one shot I shot for that test, and luckily it hit the box, thank God, and I didn't have to fire it again. So that was good. But that's why we had protection from the 15-year-old Inuit kids who were walking around protecting the camp in case of a polar bear attack. But it was a really interesting experience overall, and I learned a lot about what it took to work with the local people, what it took to work with conditions that you really couldn't predict, and sort of adapt as you went and still accomplish your mission. I will mention one fun story here. They bring a cook for the camp every year. And the cook turned out, I became good friends with this guy, and he was a high school science teacher from Texas, actually, Austin. And one day I was in the kitchen with him. I can't remember what I think he found out I was from Sri Lanka and he wanted to show me something. And so I went to see, and he had actually found a can of Sri Lankan curry powder. So I walk into this kitchen in the Arctic, and there is a can of Sri Lankan curry powder. And he said, "Can you show me how to use this?" And so my last day before I left the Arctic, he and I cooked, actually, they had pork chops. So we made deviled pork chops with Sri Lankan curry powder and dal with the wrong lentils, but that's all they had. And it was a huge hit. People came early to dinner because of the smells, the aromas. And I was sure we were going to be attacked by polar bears that day because everything smelled so good. They were banging on the table. They were like, feed us, because it was so good. And it was a really good meal. And so there you go. Everybody in that camp actually learned about Sri Lanka that day because I happened to be there, and this guy happened to have a can of Sri Lankan curry powder. So now even the Arctic has some idea of what Sri Lanka is. All right. So that's my story there. And in the interest of time, we're going to move on. So we're going to move over to Pittsburgh in the USA next. And this is where I got my thesis, my dissertation done. And so I started looking at how can we get robots to work together as a team. And then I looked at how can robots work with people. So human-robot teams. And then I was interested in human-robot interaction and what happens if people have different abilities. How does that change things? So I worked on a lot of topics. We started out here. This is what got me my dissertation. We basically simulated a virtual economy, and the commodities that were traded were tasks. The robots were given virtual currency, and they all ran their auctions to decide who was going to do what and when. And they kept re-auctioning things so that it was always optimized as best as possible. And this work is still to this day very highly cited, and sort of spawned a whole new way of looking at optimization in teams. And then we started looking at, well, what if you put humans in the mix? And so that led to some more interesting things. And as I mentioned, I looked at human-robot interaction. One of the things that I will mention, so this is an elderly blind gentleman who was interacting with our semi-humanoid robot Baxter. I named him Ratu, you can see why. And it was really fascinating because how a blind person experiences a robot is entirely different from how a sighted person experiences a robot. And so even how the robot introduces itself, everything is absolutely different. And as much as possible, I tried to get myself and my staff always engrossed in whatever that world was. So we worked with, this is one of my staff members, Ermine, getting trained to do orientation by an orientation and mobility expert who had trained a lot of visually impaired people in Pittsburgh and around the world, actually. So we always did that extra work in trying to understand fully who we were working with, what their life was like before we tried to do anything to innovate. And we always tested from an early stage with that community. So this is a blind lady who, this is one of the most recent projects I worked on with, this is one of the professors who was actually on my thesis committee. We were working and still are working on how to get blind people to cross the road safely using a combination of smart traffic lights and smartphones. So they can know when to cross the street, and the traffic light can know to give them extra time if they need more time, like if they're in a wheelchair or they're using a cane and so on and so forth. So with this work came actually my biggest adventure, because I started asking, can we invent technology that can serve the globe more equitably? So what does this mean? My motivating questions here was I started realizing, well, technology mostly benefits a very small portion of the global population. What about the rest? Why is that? And what communities are underserved by technology innovations? And do they want to be served by technology? What kinds of technology? How can we create technology that is of impact in these communities? And how can we increase the diversity of innovators? Because honestly, it becomes a very isolating experience at times when you're the only woman or one of a few people of color in any room. So my research group that I started when I became faculty, it was called TechBridge World. And literally it was about technology bridging the world. And we tried to understand in greater depth how we can create technology of impact in underserved communities around the world, with guiding principles of respect and empowerment. So I was less interested in sort of the 6-month flashy demo and more interested in how can we truly work with these communities, empower the communities, and treat them with the respect that they deserve. And this ties back to my origin story, having grown up in communities like that, where, you know, a lot of times you weren't respected if you didn't come from an affluent family or you didn't have certain resources. So I think it shaped very much my approach. So we coined the field compassionate engineering, and to this day it now persists. And what we did was basically put local partners at the center, and we built our approach around this. So we started by building partnerships and trust. We would assess needs, talk extensively to these communities, because you can't go to a community that has never experienced technology and ask them, what technology do you want? They will say computers or phones or something they've heard of, and it's a meaningless conversation. So instead, we would talk to them about what their hopes and dreams were, what their vision for progress was, what was stopping them from getting there, what were their lives like. And then we would suggest, well, would something like this help you? And it was a conversation that evolved, and together we would then design technology innovations iteratively. We would recruit and train the relevant experts to then help us make that a reality. We would always disseminate our work to a wide audience so that others could build on what we had learned. And then we would deploy and so on and so forth. So this worked actually really quite well. We were able to go global, do a lot of projects around the world. I wasn't personally involved with all of these, but this was my team or teams that were affiliated with mine. And this was also a conscious decision we made, not to focus on just one country or one area, but to try and see if there were things that spanned global understanding. So I'll couple Tanzania and Zambia together here in the interest of time and tell you about my experience. This is one of the first field trips I took in this context, where we were trying to figure out how can we meaningfully field technology innovation in non-traditional settings. So here's some examples. This was a 3-person team that went. So this is actually my youngest brother, Freddie. who is actually named after my dad, whose middle name is Frederick. But he is actually Malcolm as well. And then this is now one of my best friends, Sarah. So she's American and she now works for the State Department. And the three of us went to Tanzania and Zambia. They were two countries that we knew nothing about personally, which was important for us to see if we can actually figure out this methodology of moving into a culture that you knew very little about with limited resources and working with partners to make things work. So these are just some of the pitches. I mean, we had to learn what we could. We had to do extensive research on everything from what was an acceptable gift in that culture. There were a lot of traditions to learn about. You had to eat all kinds of fun and interesting food. I love food. So I learned a lot about cooking and food on this trip. You know, there was no kind of book online or call a hotel. It was sort of you showed up, you maybe had a booking and then things didn't work out. So you had all this stuff with you and you still had to figure out now where are we going to go stay. There were kids everywhere who loved robots. And so that was really very cool to be able to talk to them. And then we did a lot of sort of grunt work to build trust with these communities. We would clean up computer labs, show them how to remove viruses. You know, we did everything, anything that was necessary. And I'll mention a story here. So this is in Lusaka, and we were trying to get to Mongu in Zambia, which was very remote. And the only way to do it was by these buses. And this is a good example of where, you know, talking to the local people was very important because they told us, you know, if you're really going to try and make this journey, then take the first bus that leaves Lusaka. And we said, why? There are buses that run the whole day. They said, yeah, but you have to cross this national park and the buses break down all the time. And so you never want to get stuck in that park in the night because animals attack the buses. So you start on the first bus so that if the first one breaks down, and the next one that comes along, you try and get on that and so on and so forth. And you make sure you make it actually to Mongu before nightfall. So these are the kinds of interesting and highly useful tips that you get from the local community that you can't really find out on your own, and without which you can't get anything to really work. So this is actually the school we ended up working with in Mongu. These are all blind. It was a school for blind people, blind children, and these were their teachers. And music is very important in the blind culture, we found, especially in Africa. And they actually wrote us a song. We were only there for 2 days in the end, but we got a lot done, and they wrote us a song for it. So we had to learn, of course, to work with power failures. That was always fun. Entirely different models for how a classroom works than in the US. You know, people sitting on the floor, kind of towards the whiteboard. When you build technology here, multiple children travel around one computer versus sort of the US model where it would be a computer per child. And even practical things like how do you get your laundry done? And while, you know, these things are very foreign for some people, of course, you know, some of those of us who grew up in Sri Lanka were quite used to power failures and some of these other things. So based on what we learned here, we designed an internship called iStep, or Innovative Student Technology Experience. And we ran this internship for many years, where we trained students to go into different parts of the world and do technology innovation with those communities. This is my sister Beatrice, my youngest sister. She was actually in our inaugural iStep team that went to Tanzania. And this was where they worked with parasocial workers. So this was their office under a tree. There's a huge AIDS epidemic here, and a lot of children were getting orphaned by AIDS. And while there was a lot of international aid coming into the country, it was not getting distributed well to the parasocial workers who were actually dealing with the crisis because they couldn't find them. So we worked with them to build sort of a text message based system for feeding into the national database the relevant information so that the aid could flow in the correct ways. All right. So that's just an example there. Next, I want to couple together sort of a weird coupling of Ghana and Qatar. I spent a lot of time in Qatar and less time in Ghana, but they were both examples of how we can meaningfully teach topics like robotics and artificial intelligence in these non-traditional settings. So in the case of Ghana, this was one of my PhD students, Ayoko. She's now Corsa, and she actually went back to Ghana and is the head of computer science there at that university called Ashesi. She was a Dartmouth grad and very brilliant. And she wanted to help design a robotics course. So we actually helped to design and teach the first robotics course at the university level in the country of Ghana. Sorry, and this was that course. My husband actually came with us for the first week. He's more of a hardware guy, and he helped us set up the hardware stuff. And then I stayed for 3 weeks, and then Ayoko stayed for the whole summer and helped teach this. And it was really cool because we had to figure out, what were the local resources? How do you teach things that are meaningful? We gave them sort of a limited budget to use spare parts to build their first project. And it was really incredible what these students came up with. And a lot of these students still keep in touch with me, and they have formed their own businesses now in technology, and it's wonderful to see them thriving. But one of my fondest memories here was giving a talk. We gave a talk about robotics and artificial intelligence, and it was so packed. People were like hanging out of windows trying to hear us speak. And the big controversy, if you will, or question, the debate was really about the term artificial intelligence. They're a very spiritual community. There are many different religions, but they're all very spiritual, and they couldn't understand or grappled with the fact that intelligence could be something that is artificial and not human. And so it was a very interesting debate that we had there. This is us in Qatar. We, Carnegie Mellon at the time, opened a campus there, and they decided they asked me if I would come help establish the robotics presence there. And so that's me when I was much younger, and my husband now, who wasn't at the time. And so we taught some of the early robotics and artificial intelligence classes there. And it was quite the experience because we had a large number of women in the class. You can see them. And I remember the first lab was to assemble these robots. That they were, robotic kits, which we thought were fairly simple. And these women, they had never used a screwdriver. We said, well, pick up your screwdriver. And they said, what is that? They had never built Lego. They had never done any of these things. And so that first lab took, I think, 12 hours. And they were there well into the night, and fathers started showing up saying, what are you doing with our daughters late at night? And yet, they figured it out, and they all passed that course. And at the end, they gave these presentations about projects they did to the community and their parents. I think we really changed a lot of lives and minds. And this is one of my undergraduate thesis students, Noura, who ended up winning best undergraduate dissertation by voted on by the alumni of all of Carnegie Mellon University campuses. So she, her family and I still stay in touch as well, and she's doing really well, as are many of these students. And you'll see they were very segregated. I mean, this is me, and behind me I was noticing all the boys on this, all the guys were on this side, and then the women were on the other side of the classroom. And we even had a kid who was in a wheelchair. I mean, there were just all kinds of students, and it was a really great experience trying to teach in that context. And another thing I got to do when we were in Qatar was the Ictd 2009 conference. So this is Information and Communication Technology for Development. I chaired this conference. It was the first time a conference of this level was in Qatar, and we managed to attract Bill Gates as one of our keynote speakers. So this is his first visit to the state of Qatar, and So we had to also deal with the royal family in the middle of everything else. And so, you know, you learn a lot about how to make things work, but it was very successful. And I got to meet Bill Gates, the real one, who was actually a really nice guy, very smart, very knowledgeable. So I'll end my talk in India, where this was really a great example of how we can work sustainably with partners who are across the globe. This is my longest running project with the Matru School for Blind Children. It started as a school for blind children in Karnataka and has now expanded to cover multiple disabilities. So at the time we were looking at literacy and blindness, which I'm sure many of you will know. A lot of people around the world, especially in developing communities, visually impaired or blind from a young age. Some of it's reversible, a lot of it's preventable, but sadly we were not able to work on that part of the problem. So if they are blind and not literate, then their prospects for life are very limited. So we started looking at the literacy issue for people who are blind. And you will probably know that that means learning Braille. Braille is the only way in which blind people can truly be literate. And in the developing world, how Braille works is you slide a sheet of paper into this thing called a slate, and then you use this stylus to emboss your Braille dots. And then you take the sheet out, you flip it over, and then you read these embossed dots with your hand. So Braille is actually an encoding mechanism. It's not a language. So you have different Braille encoding for, say, Arabic versus English, British English versus American English, and so on and so forth. So when we started working with this school, one of the big things we found out that was blocking progress was that the teachers were also blind. And so they couldn't really give feedback very well. So the child would write 3 lines of Braille, and then the teacher would come around, take the paper out and feel and say, oh, in the 3rd character you wrote, the 6th dot was incorrect. And so it's hard enough learning the alphabet. Now you're learning 3 alphabets. You're learning, you know, ABC if it's English, then you're learning the written version of it, and then you're learning the mirror image of that to read. So as you can imagine, at that age, children really don't want to learn that much, and it's all very complicated and unnecessarily so. So they don't learn Braille. And the problem is, if you don't learn Braille, then as you go in the later grades, everything is taught orally, and you take notes in Braille, and then you study your notes and take exams, and then you pass or you don't. So most people are not, a lot of people are not getting through because of this. So what we did was we built a tutor that could actually give audio feedback as the child was learning. And, you know, this was our early version. And so you'll see sort of a larger Braille cell in the middle to understand the concept of dots and their numbering, and then they kind of graduate to a higher level. We learned a lot of lessons along the way, you know, about how blind children are taught to be afraid of wires with good reason. How encoding the teachers' voices were important because trust based on voice is a huge deal for a lot of these kids, and so on and so forth. How to design layouts that were accessible to Braille people, the feel of writing, how that's much more important, and so forth. And we took this Braille tutor to multiple locations around the world in the end, and this is sort of the end product where you could have 3 different interfaces that came on. It was relatively low cost, low power consumption, and we could support a large number of Braille languages. And we were able to test in multiple locations. But one of the things that I'll mention for this was, you know, just some of those stories where one of the children we first tested with, you know, the teachers told us, don't bother with this child. She doesn't understand Braille at all. But then we said, oh, we just want to give everyone a chance. And when she used the tutor, she knew Braille perfectly. And what hadn't been understood was that she didn't understand that you had to go to a different cell each time you write a character. So she was writing all the characters in one cell, and all the teachers could see at the end was this final product. And so we were able to diagnose this relatively small mistake, and this child's whole trajectory changed entirely. Another thing we did was with the teachers here, they only have access to text printers in Braille. Those are much cheaper than the graphic printers, which are very hard to actually print graphics in a tactile manner. But we were able to sort of trick the text printer using sort of an image processing technique, where we basically took the image and translated it into text. And so they were able to print out simple graphics. And one of the teachers there, who really hated going to the bank because they were looked down upon because she had to do the thumbprint, she couldn't write her name. She actually printed out the alphabet and studied the tactile graphics and taught herself to sign her name, and it entirely changed her life. And so I have many stories like this where, it's surprisingly small things that you do can have such a huge impact in someone's lives. So right now, I want to thank you. This is the end of my talk, but I want to mention that I did this work for 13 years or so, and I've taken a few years off now. I left academia to enjoy motherhood, and my husband's right now in the autonomous car industry. So we decided he would have that time whilst somebody had to pay attention to the kids. So I've been enjoying being a mom. And as I mentioned, my kids are, really into technology and science. My daughter is always building machines, and my son, who is 9, is now designing a robot that can eat plastic in the ocean and use the super enzyme cocktail to dissolve it into its base components and such. And so it's always a fun adventure being a mom. But I'm at this point probably a year out looking for my next adventure. So stay tuned. And then I will acknowledge that many sponsors, inventors, partners, teachers, students, everyone was involved in this research, so I couldn't possibly name them all. But truly, none of this would have been possible without the inspiration and support and encouragement of my parents and other family members, and many close friends. So thank you. And with that, I'll take questions if you have any. I hope you enjoyed the talk.
No, she can't. No. She'll come. You have to do view.
I didn't know that.
Wait, gallery view. Now you can see everybody. See, and you see your hand up. Okay.
No hand.
Then your hand is up there.
Okay. Oh, that's the same place. The speaker. No, somebody else.
So I'm not entirely sure how Q&A is done here. Should I be picking people who want to ask? I'm happy to answer any questions. I can stay as long as
Mahendra, you may want to unmute and do that.
Muted. Sorry, I didn't realize I was muted. Thank you very much. Yes, I will ask Shihan also to contribute to this Q&A, but can I start by thanking you for your wonderful exposition of robotics. Obviously, I got the very old-fashioned version, which is way behind time when I introduced it. But it's quite interesting to know that you are talking of not only allowing human robots to do what human beings do, but actually bridge the gap and do things, assist human beings in leading a better life. And I think you're also a great role model for women in general. So I'm sure the women in the audience will really appreciate that. Thank you very much.
Thank you.
Shihan, do you want me to do the Q&A or you want to do it? Shihan?
Not Shihan, just say Hema.
I have a question, that's all.
Okay. Go ahead, Hema.
Oh, thank you. Thank you for a fascinating and detailed lecture. I was thrilled to hear all the work that you have been doing. I must say that I was long time ago a PhD in biophysics from Cambridge, and subsequently in my career, I was at BT, and then I was encouraged to do a master's in computer science. So I got very interested in robotics and computing. My question is pertaining to problem solving. Now, during this computer science, etc., I came to learn languages like Prolog, Lisp, and all these things, which were supposed to help in progressing AI. But I wonder whether at the moment, is there a way of encoding or putting programming ideas through programming notation, say a mathematical question, into a robot to get an answer? Say, for instance, if you have a question like exactly how many minutes is it before 8 p.m. if 40 minutes ago it was 3 times as many minutes past 4 p.m., can you encode that question into the robot so that it might be in a position to actually supply you with an answer? That is my take on this.
That's a great question, Uncle. Yes. So the short answer is yes. We don't actually use Prolog anymore, but right now, I mean, the concept of machine learning has advanced tremendously, and it has it's loosely modeled after what our understanding of the brain is, or neural systems. There are these things called neural nets, which now everything is deep learning, and the sad truth is we don't fully understand how it works, which makes it a little dangerous. So you basically throw a lot of data at something, and it learns these patterns in sort of a very high level. That's my explanation, that it looks for mathematical patterns. I mean, ultimately, it's looking at ones and zeros. And then it can look at a data set that is different, that it hasn't seen before, and make conjectures about it, let's say. So something like what you described, Uncle, that's quite doable now. Even I would say most groups could probably write a program that can do that. And whether the program lives on a computer or in a robot makes no difference necessarily. So logic and sort of traditional AI type questions, which that would fall under, is certainly possible. The harder things are semantics. It's sort of understanding, looking at a scene and trying to understand what a human sees from that, and what a different human might see or interpret that. So, it's very easy to tell a robot, go to XY location, this. And it's a much harder thing to tell a robot, go to that cabinet and open that door, because the robot doesn't understand what a cabinet is or what a door is necessarily. So you have to sort of describe that in a way that a robot understands. So it's kind of fascinating trying to figure out, things that come so easily to humans, whereas you tell a human, go to this XY location, they're going to look at you like you're crazy. But you can say, walk over to that cabinet, and they understand very well what you're saying. But it's entirely the opposite when it comes to a robot.
Okay, thanks a lot.
Sure.
Okay, Ruan, after Jaika, then Mahesh Nirmaran. So Ruan now.
Okay. Hi, Bernardine. Thank you so much for that lovely lecture. I'm not into robotics, so I don't know much about robotics. The first part of my question is, you might think it's a joke, but it's not. Just carefully. You mentioned that you had to go on leave to look after the kids. Did you ever consider a robotic mom? That's the joke part, but the real question is about, I have heard that the difference between a robot and a human is this emotion bit. Now, do you really consider the emotions are a useless thing, or is it a useful thing? And in the future, do you think the robots will have emotions in some way? And what's the importance of emotions?
Okay, that's about 15 questions, but I'll try and answer all of them. Let's see. So I didn't have to go on leave. I should say that I chose to. It's something I wanted to experience, as I think it was Uncle Robin who said my mom stayed at home and raised us, and I think that made a big difference in our lives. So I wanted to have at least a few years where I got to do the same thing, and I was lucky enough that I was able to do it. So I'll say that. Can a robot be a mom? In some ways, of course. I mean, some humans can't be moms in the same way. So yeah, I think that's sort of a loaded question. Not a joke, but it's sort of, it's very hard. Parenting is very hard. I'll say it's much harder than robotics. And being the best parent you can to any given child is in itself an adventure. But when it comes to emotions, I think emotions are important for humans in terms of relating to things. So robots do, there are robots that have emotions, or display emotions, I should say. Have emotions is probably pushing it. And emotions can certainly be learned and manifested. There are sort of interesting things that happen in when you're trying to animate that emotion. What is it? It's really interesting. I can look at some people and I can say, oh, this person is happy. And you tell kids this, oh, what is my emotion if I'm smiling versus if I'm making a sad face. And that doesn't always translate. For example, when I was in Zambia, I couldn't take how, nobody laughed. Even kids, little kids, they didn't laugh in the streets. And I thought everybody was so sad, but it was sort of a very cultural thing in Mongu. And then, you partly realize just all the burdens they're carrying, but then there were times when smiles would break through and they were really special. And so I think emotions are very complicated. And there's this thing called an Uncanny Valley. I don't know if you've seen some of the animated movies where if human figures are animated, or humanoid figures are animated to be a little too close to humans, but not quite there, it actually has a very creepy factor. And that's called the Uncanny Valley, where you're close, you're super close, so that it's almost realistic, but you're not quite there. There's something not quite right, and it throws people off. And so some movies have failed because they've fallen into what is called Uncanny Valley. And so you tend to do more cartoonish emotions which people can relate to more than trying to get real human expressions. Now, there is, for example, a hotel in Japan where all of the humans you interact with in the reception and so on are actually humanoid robots. And so that's one of the leading countries, I would say, in humanoid robots. And they started very early, and that seems to be very culturally driven, sort of their interest in humanoid robotics partly relates to their culture and their religion and their understanding of how technology and humanity intersect. So will there be emotions in the future? Absolutely, they already are here. How they will evolve is still up to interpretation. We'll see. I have a sense they'll evolve differently in different cultures.
Jaika, over to you. Jaika?
Yeah, just a minute. Hello, Bernardine. Thank you.
Hi.
Hi. Thank you for the fascinating talk. Actually, I put my questions there on the chat box.
Oh, sorry. Yes.
Anyway.
You want me to read it for you, Jaika?
Yeah, no, I'll read it. That's okay. I'll tell you the reason why I'm asking this. I mean, in my past incarnation as an ENT surgeon, I had an interest in surgical instrument design, hence those questions. Now, I mean, it may not be exactly appropriate for you. I saw your fascinating talk, which is in field robotics. But these are questions that have been bugging me. I thought maybe you could enlighten me a little
bit. Yes,
I
see the questions. So the first one, what are engineering specialties required for robotics department in the university? That depends on the university. In the beginning, it was really sort of math. They want you to have a good understanding of math, and that's sort of all they looked for. Now they look for some, it's all over the place. In Carnegie Mellon, they look for critical thinking of some sort, innovative ideas, how have you made things work? Some of them look for computer science or engineering background. But because robotics is such a wide field, it's all about, at this stage, I would say it's still a bit of, if you want to do it, you can make a case to join. People transfer into robotics with all kinds of backgrounds.
Individual, but what I mean is, if you're going to put together a department?
Okay. So if you want to put together a department, you definitely want people who have electrical engineering background, computer engineering background, mechanical engineering background, computer science. I would highly recommend some arts because of the feature building of robots if you're going to do human-robot interaction. Math, for sure. Mathematics, there's a lot of mathematics that underpins robotics. And then it specializes after that. Those are sort of the fundamentals.
What is the relevance of art in that? I didn't quite understand.
Because if you're doing faces for the robots, so we work a lot with also psychologists, especially if you're doing robots that interact with humans. Mm-hmm. How that robot looks, the form of the robot makes a huge difference in how people react to that robot. So we work a lot with artists and with psychologists to understand how to design robots that will be accepted in different ways in different human conditions.
On that, I mean, have you found any resistance for people to accept robots like you mentioned?
Absolutely.
I found that technology is sometimes not necessarily by the users, but by the professionals, sometimes thought of as a threat to their own specialty.
Yes,
because they have been delivering something in the usual way, and suddenly there's a robot which will say, "Oh, the robot will probably displace you one day," and people
which is not entirely wrong. So I mean, the fear has some truth to it, and certainly a lot of careers have been replaced by robots, and probably will continue to. So there are ethical questions that I think roboticists should be involved with in terms of answering. There is resistance. I mean, there's always resistance to change, and you'll see the younger generations will have a very different approach to accepting a technology, usually than an older generation, but not always. It's sort of all over the place. But there is certainly resistance to change throughout the spectrum. So yeah, we encounter that, and then it's all about working with that community, whatever it is, to try and understand the fears. And sometimes you can allay them, and sometimes you can't. But in terms of surgical robots, yes, manual dexterity was definitely the first thing that people. It was not just manual dexterity. It was sensing. So you could do things like have an overlay where you could see through the body and, sort of an immediate X-ray, if you will. Then you had the tremor factors, so things that controlled the surgeon's tremor, and then it was like the manual dexterity components. Now there's much more, so you can swallow a pill can that can, again, that's sensing, or there are certainly robots that can do heart surgery, so they actually can kind of crawl into you, and it's a minimally invasive. They can work on your heart by suctioning essentially onto your heart and holding. There are robots that can do targeted drug delivery. So all of this technologically is capable. Legally, they're trying to figure it out, especially in the US. And then in terms of joining neural structures to artificial prosthesis, that is a very exciting field, I think. So there are brain ports now that they have shown where you can have, within certain limitations, your brain learn to control a robotic prosthesis. And that is incredibly exciting to a lot of people with disabilities. And that is something that I think will continue. I think soon the line between what it means to be human and what it means to be a robot will blur. We will be part human and part robotic in the future, for sure.
Thank you, Bernie. The next question by Mahesh Nirmalan, and then Roshan Asper. So,
okay.
Hi, Bernardine. Thank you. Enjoyed your talk. Hi. Thank you. Enjoyed your talk. At your very outset, you sort of hinted that the study of robotics helps you to think or understand what it is to be human. I wondered whether you would want to elaborate on that a bit more. What are your views on what is it to be human? That's the first question. Sorry, the second one is you also sort of hinted or implied that applications of robotics can be used to address inequalities in the world. And you sort of suggested some examples. But any technology will be practiced by human beings. So in that, human beings who are driven by, I don't know, whatever drives human beings. So in that context, do you think robotics will actually address inequalities in the world, or makes inequalities worse by concentrating resources within, or profit in fewer and fewer hands?
Okay. All right, deep question. So what does it mean to be human? I think that can take a talk on itself. I think this is a fairly personal thing for each person to decide what it means to be human. But the more you work with machines, I think the more personally you try to internalize, you kind of realize, well, okay, you know, this thing is doing things that I thought I was capable of. What makes me different? And you start asking that question in a deeper and deeper way. And I think, you know, one of the most humbling things as a roboticist is to become a parent, because your kids, they learn through the most controlled environments, and they learn to do things so much faster than any robot can. that we struggle to get robots to be able to do. Even things like, you know, dropping your robot and having it stand back up took so many decades of research, and kids learn to do that in weeks, right? So I don't have a crisp answer for what I personally believe is human versus not. Some will argue, you know, about a soul. I don't know. It's intelligence of a certain kind, semantic intelligence. The ability to abstract things from a scene and create sort of these imaginative concepts around it certainly does not exist still. There is robotic art, so robotic poetry, robotic script writing, and even robotic visual art, but you can see how it's still copied off something that a human imagination has. So when it comes to imagination, that's still, I think, something that is squarely human. So that would probably be my safe answer there. In terms of inequality, I have never believed, and I don't think ever, robots will be a magical solution to anything human, right? So ultimately, if there is inequality, you're right, there is some sort of human structure in place that is protecting that inequality and that created that inequality, and ultimately, that's what needs to be destructured in order to create a more equitable system. What technology can do is try and shift that balance if applied correctly. So you can, for example, you know, people are now able to get things that are going wrong, people being mistreated with the global media. You can actually get visual evidence of this out to the global media, which then puts different pressures on the systems of power. Now, does it also create more problems? Of course, because technology can be manipulated by humans right now. And so now you have fake reality, right? So people who can doctor videos to create things that look real, but they're not. So there's a lot of ethical debates right now. So I know the people who created that technology that was that allows you to make these fake videos, and you know, their motivation was very good, but it leads to all of these issues that you have to think through. It's just like cloning or something like that, which, you know, we need to have much more informed debate about all of these things, where technologists play a role in trying to help understand what it is that might be coming down the pipeline if these technologies come into play. So that's sort of my short answer for a fairly a question that we could debate on for a long time and should debate.
Roshan Aswa.
My question too was on those same lines. Firstly, the credit to your proud parents for raising and nurturing such a unique talent. My question was, I mean, with humans, you know, quest for immortality, Even if you provide, the humanoids, and even if you were able to simulate the whole of our brains and transfer or whatever it is, will there ever be, whereas a roboticist, would you ever say that they will acquire the elegance and more the consciousness of the human mind? Have you ever been fooled into thinking that? Or have you come close to it?
It doesn't exist now,
Yeah.
but can enough of a human essence be preserved immortally? That's arguable. It's possible. But what is enough? I don't know, right? So, there are certainly elements of it. So is it, if someone, so say if I found out I had some disease that, I'm going to live for 5 years, I would certainly try to preserve as much as I could of who I am for my children to see in the future, to help comfort them. We started this long time ago. We would write letters or take photos or whatever, videos. So you can imagine an evolution of something like that, where you can even create, a bot, if you will, to not necessarily a physical robot, but an artificial intelligent bot to try and capture some of that essence for the future, so that your child could actually speak to some segment of you and give them comfort. So there are things like that, but there's a lot of research into both cryogenically freezing people, which is another whole debate, but also they want to do that with the expectation that we will be able to immortalize human conscience, and then you basically take that conscience and put it into your brand new body, whatever that you want to be. And there are a lot of ethics in that too. It's certainly not possible now. It won't be possible. I can't see, unless there's some crazy breakthrough in the next decade or two. But eventually, maybe. Will it fully capture you? Probably not, ever. We are too complex.
Thank you.
Okay, next Mevan, followed by Zita. Mevan, please.
Thanks, Bernardine. I'm Mevan, and I have probably little different questions. Number one, I didn't get exactly. It's a simple question. Where in the US you are based in right now? The other question is actually about Bill Gates. Your encounter with him. You mentioned him being intelligent, obviously, and he has shown that his capabilities are way beyond his wealth, and so is the case of his wife. These are one-of-a-kind people on Earth working on large issues like sanitation, environment, the pandemics, and so on, handling big issues and energy. And those who are interested in Netflix, there's a series about Bill Gates' brain, which is a fascinating documentation about how he thinks. You are one of the two people I think who have met him personally. Sort of, can you elaborate more on it? Because I think this is a very fascinating human being. In my view, again, this is my personal assessment. This is the guy who values each second of his life, because he mentioned that if he is worrying about losing something, he's worrying about losing his brain. So he doesn't want to have a stroke, kind of a thing. And because that's the single most valuable thing to him in his life. Did you get that? I mean, sorry, I might divert your attention from your main topic here, but this is
it's fine. So okay, first question was where I'm based. That's in Pittsburgh, in Pennsylvania, in the United States. That's where Carnegie Mellon is. So that's I never left after I came. Bill Gates, yeah. So you have to understand that the context within which I met him was very regulated. It's not easy. There were so many people trying to tell me what to do. I actually had to go into hiding the week before the conference because everybody wanted to meet Bill Gates and everybody wanted a front row seat for his talk. And I said, if you guys keep doing this, I'm going to just put one line and everybody can sit in the front row. But it became a very political thing because, everybody wants a piece of Bill Gates. But I think probably the most useful encounter where I got some sense of who he truly was there was a group of 8 of us who got to sit with him for about 20 minutes. And I have a picture somewhere of me right next. I got to sit right next to him because I was, I think, the only woman in the room. But he was incredibly well read. He's always well prepared. Like, he knew the research I had done. When I started talking about my stuff, he said, "Yeah, I read this." He's very down to earth. He speaks very calmly, and it's very clear. You know, there are some people who you can tell they're thinking. They have thought through what they're saying. He's very intentional in what he says. He doesn't just react to things, but he also has emotion. Like, you can feel he's passionate about things. He's not just saying things because they're meant to be said. I've read a lot about Melinda as well, and I read her book, Moment of Lift. And I think, you know, they not surprisingly, I guess, had some of the same issues about, well, you know, how much of childcare is Bill Gates doing? And Melinda was like, dude, you know, you got to help me out here. And he ended up having to drive one of the daughters to school more often. And so, you know, he's human. He's just like all of the rest of us and grew up in a certain context. But he's humble enough to acknowledge that, and has, I think, partly through Melinda's excellence, but maybe in him recognizing that excellence, also learned to be more equitable in that partnership and given her opportunities where, you know, some people might not have. So I give him credit for that. He was really easy to talk to, at least from my perspective. Some people were a little awestruck, but I have been blessed not to have that problem. I've met a lot of different people, and you know, people are people ultimately. And so, but yeah, I enjoyed my meeting with him. I thought he was very thoughtful, and he really cared, which is unusual for someone with his position in life. I don't know if that answers your question. Sorry.
Thank you very much. I think Zita wanted to know whether you could tell us more about robotics and surgery in the current state of affairs. Maybe it's not your field, but would you know something more about robotics application in surgery?
Yeah, so I mean, I mentioned some of this. I think one of the things that's been interesting is sort of the Vinci Robot is probably the best known.
That one?
Who's talking?
I'm sorry? Oh, sorry. Okay.
Actions.
So there are certainly robots. I think the biggest thing robots have done is improve the accuracy of surgery by giving surgeons more tools in terms of sensing, in terms of tremor control, in terms of smaller incisions, so you can actually put smaller things inside and then look on a bigger screen. And it's meant different skill sets that surgeons have had to learn. But I know there are a lot of partnerships with medical groups, even here in Pittsburgh with the UPMC system and the Robotics Institute, where they are robots are capable of doing some surgeries entirely on their own, and it's a matter of when people are ready to allow that to happen. I think that, you know, open heart surgery is no longer necessary because in some ways of technology innovations, a lot of surgeries, the chances of infection have been reduced because of the size of the incision being reduced, is my understanding. I know very little about surgery. Optical surgeries, you know, the laser surgeries, the tools have been improved, the sensing has been improved. And at some point, you know, this is maybe one area where a robot might adopt a certain surgeon's strategy or style in doing a surgery. That might be possible in the future, where I know we try in science to be objective, but if we are honest, there is a style to everything that we do that's not entirely objective and not necessarily a bad thing in some cases. So I think in general, I don't know how to answer that question, but I do know that robotics is impacting surgery now. The capabilities are far superior in technology than what is available on the market. And a lot of that is sort of working through the legal system and the ethics of robotics and surgery.
I see.
But
Ruan.
also
Carry on.
I also wanted to make sure that it's not just in the tools of operating surgery, but also in, we use MEMS technology to grow organs, so artificial organs, prosthetic limbs, all of this technology is impacting that aspect of it too. So as a human surgeon might be implanting the organ, but the organ would not have been possible without the technology. So.
Thank you. Before I give Ruan and Mahesh, is there anybody who hasn't had a chance to ask the question who I have not seen or heard, or is there anybody else who wants to put your hand up? Anybody? Sarat, do you want a question? Because you're unmuted. No. Okay. Okay, then over to Ruan.
Bernardine, I have loads of questions, so I might come again if there's no other questions. But my question for you is, at the moment, robots are servants of humans. Now, by the looks of it, very soon they will be probably equals or even our overlords. And when do you think Isaac Asimov's robotic laws needs to be seriously considered in robotics?
Yeah, so there is actually a whole field called ethics in robotics, and Asimov's laws are the starting point for that. The robots won't be humanity's overlords anytime soon. Will it be overlords to some humans? Maybe, because of the inequality structures that exist within society already. I mean, there's already complaints about why is technology monitoring my break time and informing management about, how long I took for this break or that break, right? So you can see the elements of it already emerging, let's say. To have sort of Terminator-esque robots, we're not there. And I hope we'll never get there in some sense. But AI is definitely playing a bigger and bigger role in sort of shaping our reality. We can't use even a microwave, toaster. Everything has some element of computing in it now. And this is something we should, as a global society, have more discussions about, how much of this do we really want? How much of it do we want to be able to control? Our homes are getting increasingly automated, the video doorbells, and all of these have implications in privacy and security and what can be hacked. Our identities, that are digital, have huge implications in our credit histories and such. So there is no easy answer to that. It's something that's as complex as society, and we have to be able to, in my opinion, the most important thing is to create democracy within that, in the sense that people should have a say in how much technology can impact their lives, and should, and in what ways, and be able to make informed and consent, if you will, or understand, make those choices with a good understanding of what it really means. And that doesn't exist right now, and that's something I hope will happen more.
Okay, thank you very much. Lakshmi Pereira, followed by Mahesh Nirmalan. Lakshmi, unmute.
Okay, actually that was very fascinating and a talk. I mean, I'm quite new to the subject, and a woman doing such a lot to science and this field is really, really inspiring and encouraging to all the young women. And my question is, you have spent a lot, I mean, the world has spent a lot of the knowledge, funds and everything to create these robots. Is it being used, and are the full potential being extracted by the society and by the governments? Because you have made such an effort and lots have been put into it. So does it go parallel with the need and to utilize? So that is one question.
Yeah.
This
Okay.
question is a simple one. Does the knowledge of human anatomy help in making robots?
Okay. I'll take the second question first. It's not just human anatomy, but also animals. We study a lot of biological structures. So, you know, cockroaches have informed robot mechanisms, geckos, fish, and of course humans. You know, we study a lot of anatomical structures and use it to both create better robots, but also then use robot models to, we have actually been able to use robot models to then correct some things in our understanding of anatomical structures, because people think, oh, this works in this way. And then we can build that and say, yeah, it doesn't quite work that way. So now we have to change our understanding. And so that's been helpful in both directions. In terms of, has it been worth it? Has it been spent correctly? I don't know. That's a big question. Part of it is that in any field that's new, you have to initially invest with some belief that it's going to pay off, right? So that's sort of a startup investment, if you will. So there was certainly an initial phase where, you know, AI was overhyped, and it died because of that for a long time, where people were expecting, I think they were called the Jetsons, I don't know. And, you know, they tried to do too much, or they oversold it. And I've been very careful about hyping things ever since. But I mean, I wasn't part of that initial phase. The AI has certainly matured a lot more, and so has robotics. A lot of it's being used today in ways most people don't know, in the military, in you know, that's in space, in NASA. Several of my friends work there. I had the opportunity to work at NASA. I actually worked there for a summer. But it's in the everyday person's life, not as much, right? And part of that is industry and certain things where the industry was not mature enough. We're getting there now in the US. In different parts of the world, I mean, farming is done almost entirely by robotics. So it depends. Part of European countries. In East Asia, there's a lot invested in elder care and in assisted living or independence in later age groups. There is a lot of, I mean, the Japanese toilets are amazing. Even that's very automated for people with disabilities. So it'll be interesting if they pull off this Tokyo Olympics to see what the newest technology is there, because they've certainly been working on that for years and we've been part of that. But
you have to change the attitude of the people as well, isn't it? To trust the robots. So
yes. So
for instance, when we went to Japan or China, I think, and we had to learn how to use the toilets. Not only the toilets, how the rooms were lit. It took about half an hour for us to learn. Otherwise, we were without lights, and so the things like that. So people also have to be educated in parallel.
Absolutely.
Yeah.
Right. Yes.
Make use of the gadgets, isn't it?
Yes, for sure. Because people get used to doing things in a certain way, and it's not always intuitive, right? So you see that every time a new smartphone interface comes out, you have to now figure out, well, what were they thinking here in terms of, you know, how I do even the most simple things. And so if you translate that to using a room or, oh God forbid, a toilet, you know, that's hard. But it's also, I mean, some of the people I've worked with, for example, who have severe disabilities, it can be life-changing for them, and they're willing to learn anything just to be able to go outside or to have a different sense of security when they're, or independence when they're walking around. So it all kind of depends on that need and how much of a drive people have to accomplish something. I would say that there's a lot more technology than the general person is benefiting from in their everyday life. And how to make that happen is unclear, because each country, each city, each state in the United States has their own governing system, and who decides what gets deployed where, that's hard.
Yeah, for
that's not an
example,
easy.
I posted this notice to participate to so many people whom I thought would be interested. I mean, quite intelligent people, quite matured people, but few of them returned and said, no, we don't use Zoom.
Yes.
So,
Okay, I think I'll pass on to Mahesh now. Mahesh?
Yeah. So thank you. And
Okay.
thank you very much.
Mahesh?
Thanks, Mahendra. When it comes to the progress of technology or how technology is developing, if you look at it very critically, you can see two things. One is you identify a need, and then you go around looking for a technological solution to address that real need. Sometimes, and increasingly so, you have the technology, and therefore you go around fishing for a place or an application for that technology, what that technology allows you to do. In that spectrum, where do you see developments such as robotic surgery? Is it really being driven by a real need, or are we trying to do robotic surgery because it's technologically possible to do so? What is your view on that?
Okay. In terms of surgery, I think it's largely driven by need, or at least perceived need in some cases. I think there is a lot we can improve in precision and accuracy. And that's what it comes down to a lot of times in surgery. So some of it is simply getting the surgeon better information, right? And also real-time information. Some of it is helping a surgeon overcome whatever environmental factors are ongoing so that they can focus on the surgery. Some of it's controlling things like tremor so that you can do better surgery. And then at some point, if robots are capable of doing better, it's the question of whether, it's the right thing to do, whether the surgeon should relinquish some tools to entirely be automated and just oversee it. I don't know. But in the surgery area, at least primarily, I've seen a lot of partnership between the medical community and the robotics community. And so it tends to be largely driven by at least perceived need. In general, that's not true. You're right. We have a saying that says, when you have a hammer, everything starts looking like a nail. And that's something we try really hard to avoid. I have certainly drummed that into all of my teams, saying, do not walk in there with a technology solution, first sit and listen. And listening is something that people don't have good skills in increasingly. So it's something we have to actively teach. And listen humbly, and don't, a lot of people in my field, and I tend to do this sometimes, and I have to stop myself. You're listening to something, and then you listen to the first three things, and you've already formulated your answer in your head without listening to the full question, because you're just so in this mode of moving fast. But it's not always a good thing. So sometimes you have to slow down and take a breath.
But even with the surgery, I'm interested that you use the word perceived needs. I would actually put a capital P on that word, perceived.
Fair point.
Bernardine, on a related question,
Yes,
are there any international regulators about how we proceed with things like privacy and individual freedoms? Because
there are some. How much teeth they have is questionable, right? I mean, you can have international bodies so-called regulate a lot of things. How much they can truly regulate is questionable.
Because it'll be very interesting for me to see how China advances in the next 10, 20 years.
I can tell you that no international group can regulate anything in China.
They are not,
I mean, practically speaking, it's not happening.
They are not hampered by little things like democracy and, people.
No, exactly.
Anyhow, did I see somebody else putting the hand up now?
No questions from Uncle Robin. Oh,
Uncle Robin. I thought Indrani Antaripalli had maybe she was just putting a hand up. Okay. Where's Robin? Robin!
I'm here.
Ask a question, for heaven's sake. Come on.
No, I actually have been, I sent a chat message to Ruan that, I mean, what can I say? You know, I'm gushing with pride.
Okay,
Sri Lanka, for Malcolm, for Bernie. Bernie's just putting her head down. She's hiding now because she hears me. I don't know, you know, if you see Papa there, that's Bernardine's dad, and then Bernie Dias there is the mom. I'm just so proud of Bernardine, the parents, and then her brothers and sisters. My question is, do we have groups like this in the United States of Sri Lankans that you have talked to?
Not that I mean, I haven't talked to any, but I'm sure they exist. I don't know. I mean, there is a Pittsburgh Sri Lankan group. I've taught candy and dancing and danced for them, but no, I haven't talked to her.
So just to follow up then, I think we need to co-opt you into our Sri Lankan Literary Society. It's kind of literary, but you can see we talk on very varied topics. It's, if you have gone on the website, it's in, I have,
yes.
I mean, it started 10 years ago with very, very limited sort of goals. I only started 1 year ago in this, and I'm glued to this thing every Sunday. Thank God I don't have to go to church. But but I'm telling you, he would
think it's rather ironic to thank God about that, but okay.
I know, but that's not, I'm one of these people who believes in the rituals. But I'm also very, very grateful that you're here. I think you should be co-opted into being a member of our SLLS for two reasons. One is we can bring younger people, and motivate them, inspire them to do these things. For instance, you started at Hamilton College. I mean, you don't know how hard I'm trying to get my my high school junior to look at Hamilton as a place that, a great university here. But, that having been said, I think you will inspire a lot of our, in many instances here, grandchildren, to do great things. So please consider joining us. And then I'm going to just display my ulterior motives right up front. I think Mevin asked you a question, and he's the US representative on this thing. I think you need to replace me, and then you can recruit with Mevin. You need to recruit with Mevin lots of people of your ilk to, enlighten the rest of us. So
replacing you, Robin, is impossible. That's
right.
And nobody can do. Yeah.
I'm happy to talk to your junior, though. If they all have questions about Hamilton.
Thank you very much for your observation, Robin. I see 3 hands. Shihan is number 1, followed by Ruan, Roshan, and Mewan. So there are four people. So who's going to start first?
Right, more questions.
Who's going to ask first, Shihan or Mewan?
Hello.
Okay, Hemal. Okay, Hemal.
Thanks again for this wonderful discussion. So many interesting questions coming up. And now I will, my second question is going back to the basics, so to speak, on operations systems, because this is now becoming critical for the use by general populace. I know that I was brought up technically on VAX VMS and then Unix and so forth. But now when it comes to things like Microsoft Windows, and even professionals who have businesses and computing businesses say that it's terrible system, that it can crash, it's so complex. Why don't they kind of try to simplify and have a system where a lot of old people can use it properly, like the Lakshmi, I think, mentioned about their experience in Japan. Unless the the systems to operate the computers are made simple, they say that even 90% of the computer power is not used because nobody can use it because they don't know how to give instructions to operate. So I wondered why this was not the case. But then one of my friends in business, and he's also a computer expert, told me that a kind of a Machiavellian theory that it is to make money. In other words, what he called version money. Because if they change the version of all these operating systems every 6 months, everybody is forced to buy the new system because otherwise the competitors will overrun them. So there are so many issues. I'm sure you know about the complexity, but I wonder at the base level, isn't it very necessary to get it to a very simple level, not as simple as operating a telephone, but something like that, that people could, easily use a range of basic commands and go around the system without too much trouble. So I think there's a lot of meat in that for you.
Okay.
Okay. So your friend is not wrong, sadly. There is the business side of this where, they have the money to do the PR, but then they have to keep making the money. So then they create problems that they can solve, so to speak.
Sure.
Sometimes they don't solve it well. There are the freer versions, but then they don't have the money to invest in the PR. And so, yeah, that's a silly problem, honestly. But in terms of operating systems, that has changed a lot. The chip technology has changed. And in fact, when AI first beat Kasparov in chess, what it took was actually a hardware change to the system because it was the only thing that allowed us to think deeply enough down that chess tree and the game tree, so that we could beat Kasparov. There are some fascinating books about that. But it's there are all kinds of now changes to both the hardware system in how these operations happen, as well as the software that runs on it that has to change accordingly. And that's changing so fast, it's going to be hard to keep up. So the question is, can we do then an evolving graphical user interface or graphical interface, really, or user interface that can help people keep up with that? And that's a fascinating question in itself. I can tell you an example when there was this system that was introduced into a village in India that their people didn't have high levels of literacy, so they made it a speech-based system where you can speak to the computer in Tamil, and the computer could then provide whatever information you were searching for. It was primarily for farmers, and they were looking for weather information and crop prices and such. And so they brought these people to test it, and they asked them to speak to the computer, and they refused. They didn't have any concept of speaking to a computer. So what they did was they gave them a telephone receiver that was not hooked up to anything, but they understood to speak into that. So they would just speak into this, and then the computer would hear them and give them the answers. So it's really fascinating how humans associate certain behavior patterns, even with physical objects or concepts, and sometimes it takes that bridge to get them to adapt. So in itself, human-computer interaction is a field in itself. You can earn degrees in that, and so there's a lot in that question. I'm sorry, I don't have a simple answer to any of these questions.
Hemal, I can't help but comment. You mentioned the telephone. I don't know if you've seen that little video of two young people trying to use a dial-up telephone. They had no clue at all what to do with it. Absolutely no clue. And any old grandmother will phone anybody on earth. Ruan, then Roshan. And then I think we'll stop at about just past 4. Okay, Ruan?
Okay, my last question, Bernardine. We tend to think of robots as humans. So in other words, we think of a robot as something that's a body and something which has a brain, both. Now, you and I know that there could be a brain without a body. The closest example I can give you is something like Alexa. We can, ask Alexa to do things, but there's no body as such. Now, my question to you is, how close are we to get not just like Alexa, but more advanced brains only without any body, which can do things even without do things for us, even without even asking, like setting up the ambience.
Yeah, that's quite easy,
or heating or whatever, and probably to a degree of controlling the.
Yeah, so in certain contexts, that's easily doable. You can learn human preferences and you can set things up. So there are digital assistants now that can do things. There are digital translators that can help. So I can walk into a community, especially in disaster response, where medical people will show up and they need to consult with a patient, but they don't speak the language. So there are a lot of things like that that certainly have advanced and are very helpful. There are home automation systems that can understand your preferences, so it'll play a certain mood music when you come in from work, or it'll adjust your temperature to what you like, and so on and so forth. And those things are not hard to do. In the true sense, though, I mean, it's of course much more complicated, and Alexa has its drawbacks. I do not allow Alexa in my house. Because there's also at the back end of all of these things, there's a lot of data collection that people don't always realize, and privacy, or especially your children, if you have young children in the house, that can lead to all kinds of dangerous situations. So it kind of depends, but there's also a fascinating aspect of this in terms of autism. So with certain autistic kids, we've realized that they are actually much more willing to speak to a robot because of the sensing overload of humans and all of the emotional cues, and can learn to interact better in human society by first starting to interact with robots. So there are really kind of fascinating pockets where robots can be the bridge to human interaction. But again, it all depends on the context and how well it's done.
Roshan Aswa, and then Niroshi Nirmalan. Roshan Aswa.
I think Mevan had a question too.
Oh, Mevan. Okay. Oh, sorry. Yes, Mevan.
Well, yeah, I won't take much time, Bernardine. I just want to agree on Robin on one and disagree with him on one. I certainly agree with him on that I would like to invite you to be part of the society here, because it's a much desired need that, and I live in the Midwest, and we don't have a similar organization in the US. There have been some attempts, but it never takes off. But at least be part of this would be very useful. The only thing I disagree with Robin is that he paired me with you. I sort of he implied that I am younger, but I'm more to the uncle's generation than your generation. So
I don't know. I'm older than I look, I suppose.
Anyway, I hope you'll join us to particularly get connected to like-minded people, plus being a role model for younger generation as well, and your gender on top of it, in a lead role. And these are a lot of pluses that the younger generation can emulate and learn from you. So please be part of it. I just want to encourage you to come along and be part of the organization. Yeah.
Thank you, Mevan. We'll Roshan Aswa next, then the last question from Niroshini.
I was going to ask you, and in fact, you just touched on it, the idea that, the theory of mind that still, with autistic children, they lack the theory of mind. And yet I was so fascinated that they're able to interact with the robots who, in essence, are they, they're mechanistic, I would say, but do they really have some sense of that theory of mind?
I don't know. I think that it doesn't work for all. Autism is according to my very limited understanding, a spectrum, right? So it certainly doesn't work for all autistic children. But I do know that for some, it has made a huge difference in terms of helping them to learn to interact with other humans, and they seem less afraid or overwhelmed by the robots, and you can control with the robot how those sensory cues are increased over time, and that's something that's harder to control with humans. So that helps them to, I suppose, in my very lay terms, build up that mechanism for dealing with what seems to be essentially a sensory overload that they feel if they just walk into a human encounter. But how much of the theory of mind is in there, I couldn't answer that. I'm sorry.
Thank you.
Okay, Niro, over to you. Niro is also an academic, and as you might have noticed, she's also a female.
Oh, no. Thank you. Just a biologist, though. Thank you, Bernardine. That was a fascinating insight into an area I know nothing about. So my question is, with your background and with your passion, and you come through as very, very inspiring. With regard to the future evolutionary trajectory of AI or robotics or whatever, what is your overarching emotion? Is it excitement, or is it fear, or is it both?
Overarching is excitement, for sure. I believe very strongly that we get to shape what it does, and we're still at that stage. And so my mission, if you will, is to bring as many voices and backgrounds to that process so that it continues to be exciting rather than fearful. I
hope you're right, Bernardine.
I hope you're right, yes.
Yeah.
Me too, yeah.
Because this is not the first time human beings have faced the question how to deal with something new, something which has tremendous power. You can only use it for the goodness of human beings, or you can do damage with it. And we have somehow reached that balance. That will never go away. So thank you very much. I think Robin had his hand up, and that will be the last one. And before I hand over to Robin, I just want to say hello to Rosemary, Indra Anthipali's daughter. Hello, Rosemary. Okay, Robin.
So because we are concluding, and I'm sure Mahendra will have his own vote of thanks. And I figured I have to thank you again for agreeing to participate when you had no clue who was calling and who was asking. So I don't know, my Tamil used to be good, but it is not very good. But in Tamil, I'll say Nandri.
Wow, okay, I learned something.
But in Sinhalese, I will say Obage Demaupianta. ඔබතුමයටත් අපේ හද පත්ලෙන් පැන නැගෙන ආදර අවංක භක්තිය ස්තුති පූර්වකම පිරිනමනු.
Oh, that's quite a mouthful.
I'll have to go read Subhashiti to understand all of that, but thank you. I did understand.
Okay, I think I'll bring proceedings to halt now. Firstly, by thanking Bernardine for a most stimulating lecture. And also, I'm not saying that all academics are like that, but you're such a cheerful person. It's lovely to listen to you, always laughing and making us all happy. So that's lovely, not very serious. Although I'm sure you're a very serious person. I want to remind people that if you want to show your appreciation in any way, you can always look at this website, the challenge, for a very worthy cause, in my view, and do whatever you can to support it. So that's that.
Thank you.
Okay, so let's can you all unmute, please? All unmute.
Unmute.
All unmute. Right. Okay. Now put your hands together and give a clap to the team.
Thank you.
Oh, Bernardine. Remember that song?
Thank you.
I'm sure Zita remember that song. Zita? Okay, well, have a nice time. Rest of Sunday. All the best. Bye.
Thank you for the invitation.
Bye.
Bye.
Pleasure.
Bye.
Bye.
Really nice.
Bye.
That's really good.